So today we are mostly going to talk about hardware Trojan, and then in the second half how we will basically detect them with different technique, including AI. Sir.
Is it ready? Good morning. Today we are going to talk about hardware Trojans, and here is a rough outline. First I am going to talk about how to design them, what they are. We will delve into the details, so that whether you want to work in the designing of hardware Trojan or detecting hardware Trojan, you will be able to do that. And when we talk about detection in the subsequent lectures, we will primarily focus on different techniques, and many techniques I talk about, all of them can be used as an AI metric, but I would specifically talk about how zero shot learning, explainable AI as well as reinforcement learning can be used for detecting Trojans. And then finally, I will talk about, now that attackers know you are using AI for detecting Trojans, so then how would they attack your AI model itself, and we will talk about AI Trojan, how would a Trojan look like in the AI model itself and how do you mitigate. So, to set the context where hardware Trojans comes from, we need to talk about the supply chain vulnerability. There are many places they can come in, and supply chain vulnerability, the starting point itself is the integrated circuits or hardware is very complex, systems are very complex. In early days, even 20-30 years ago, companies were able to design everything on their in-house, but because of the complexity, there is not a single company in the world they can claim they design everything in-house and they integrate everything in-house. So, maybe they are taking processor from company ARM, digital signal processor from Texas Instruments, different analog component from analog devices. So, they are buying components from different companies. It is not just the component, the components are getting through compilation, synthesis, testing, fabrication. So, that is basically causing all these problems. So, what I did for one of my sponsors, and I am not allowed to tell the name, I took the devices and trying to figure out where the pieces came from. So, this is one of the router, and when you think of router, do not underestimate it, this is a multi-million-dollar router which most universities or different countries basically buy the route to route different types of traffic at institute scale or at the country scale. And those components when I plotted, so basically as you can see, it is all across the globe. Now, you might say, well, I do not see anything in South America, Africa, Australia, but it just for that device, that SoC, it did not happen. You take another SoC, you will find that. But the funny part is, I mean, most interesting part is actually what you see, that is a static view of the story. In fact, maybe some component got designed in San Jose or Santa Clara, it might have traveled to India for kind of testing, scan chain insertions and so on and so forth, might have gone to Europe for integration, might have gone to Taiwan for fabrication, might have gone back to USA for final assembly, and it might have made many trips around the globe crossing different hands and different companies, and that is where the sources of vulnerabilities are. When you keep your secure document inside your room, inside the locker, that you know when you want to access it you have. If that is changing hands, one of your friend is picking it up from the postal department, then they are dropping in their friend's house, their friend's house has tiny kids roaming around and tearing off things, the reliability of your document would be in question. Until you see it and know it is in single piece, only then you know. And who are these people? So, always we do not have to assume that attacker basically meaning all bad or evil people, it is a combination of them. Some employee could be a state level spy, country level spy, they are trying to doing spying activity. So, exactly whatever Israel did on the pager attack. So, it could be a state element, they have a vested interest, they are willing to spend as much money as needed, then you can't do anything. Even it could be a disgruntled employee who did not get promoted or got fired, and that is why when they fire an employee they immediately lock everything. So, it could be a combination of all of them. Even it could be somebody not really malicious. So, like the way when we talked about finite state machine vulnerability, we talked about the synthesis tool generated something which happens to be vulnerable, and Dr. Korfa spent a day of lecture on talking about how do you mitigate, mask and blind and all that stuff. So, even compilation or synthesis tool introduces vulnerabilities which later somebody can exploit. Later meaning when the device is in deployment, is in use, somebody can mount a vulnerability, mount an attack because this has a vulnerability. So, the supply chain, and in fact if you think about it, when I talk about security, I forgot to mention security is not about the way you think about security. In fact, if you talk to the Ministry of India, they will talk about food security. Do we have enough cultivation, enough grain in store? If it does not rain for certain amount of months or years, are we okay? Do we have some kind of conflict with other countries in terms of import and export? Do we get enough grains that our people in India need? So, that is also food security. In fact, many of the rare earth materials in specific countries, if they are hostile to you, they are not going to give you those rare earth material, then you cannot design chips. If you cannot design chips, then you cannot have cars, or cars going to be extremely expensive. So, that is basically going to be a security problem, national security problem. So, sometimes security in the sense we think, oh, somebody stole my iPhone, somebody hacked my bank account, that is really microscopic problem. It may be a huge problem, somebody dies in my house, it is a disaster for me and my family, but for rest of the crores of people it really does not matter. They do not cry for somebody dying at my house. Same analogy, when your bank account gets robbed, it is big deal for you, but not as a society, not for a country. But if there is a national level attack, whether on the food security, national security or any of those, then that is also a security problem. And the vulnerability, supply chain vulnerability, if you recall, when there was a boat jam in one of the traffic lane, and then things were not moving, all these big ships are not moving, suddenly every prices have gone up. During COVID time there was that supply chain problem. So, that supply chain security problem and this problem is same, it is just that it is a microscopic. We are talking about components inside a system, software, hardware, and when other people talk about supply chain security, whether food, grain, car, rare earth material, fuel, whatever supply, that is also a supply chain security problem. Any question on this idea that this is actually changing so many hands? Now, at some point you might be thinking, wait a minute, and throughout this discussion I would be using the term potentially untrusted. TSMC is a multi-billion trillion dollar company. Why would they insert Trojan in your device and tarnish their reputation? They won't. They won't. They would be interested in buying fabs from Intel and all that. They want to expand. They want to expand their portfolio. But the thing is, it is not necessarily any company knowingly doing it. In fact, my first company was in Texas Instrument. I got salary hike, I do not remember, 500 rupees, because my salary was 7,000 rupees, it is 500, 200 could be. I was so happy jumping around. I asked my cube mate, how much is your salary hike? After 1 year, that guy said, I am not an employee in this company. Now, this is a contractor from Intera Systems. I am not even remotely suggesting this guy has anything negative to do with it, but I am saying I am sitting with somebody for 1 year in my cubicle and I do not know that person is not even an employee of my company. So, you could imagine all these people working in different companies and the things changing hand, you cannot just trust. If right hand cannot trust the left hand, then you could imagine this whole trust business that you can assume safely, oh, this is from a branded company, therefore, it should be reliable. We cannot do that. You have to do your legitimate thinking and verification. And so, is it clear that this supply chain or this huge global supply chain is essentially the cause of concern for security? If there is a single room, single company, everything developing, that would be extremely reliable. Now, it is not should not be a surprise, that is why we see so many types of problem, and in this today's lecture I am primarily focusing on problem at the design stage, little bit of fabrication, but what I am not going to talk about, that is 90% of the story I am not going to talk about, which is all the way from assembly, distribution, lifetime, end of life. Let me talk about end of life, so that you get an idea. So, many rich countries, what they do, they send their garbage to the developing countries. I did not wanted to say poor countries. So, they send their garbage and they take all the good stuff from there. A ship full of garbage comes in, and that garbage meaning old computer and old car and all that stuff, that goes to those countries, and from those countries all the good stuff goes back in the ship, and everybody thinks they are the winner, and you know who the real winner is. But what happened over a period of time, the dumping ground, somebody figured out about 30-40 years ago that in the computer or car whose lifetime has expired, some of the chips are still working. Original intent was you take the chip, melt it out, there is a minuscule gold, lot of rare earth material, extract it and then sell it, and that is enough money to do this recycling business. But some smart dude figured out that those chips actually work. Then they started coloring and painting, and it is a $1 trillion business actually, this recycling chips, and that creates significant security vulnerability. You buy a new stuff and it does not work, then you know it is either pirated or one of those recycled materials. So, therefore, vulnerability is throughout the stuff, but in this lecture I will primarily focus on software, hardware, code level, programming, design level, little bit on the fabrication level, but I am not going to cover rest of that stuff. And Trojan is just a name, it is basically somebody maliciously implanted something, right. And in fact, people do that all the time. If your kid is not listening to you, that basically means somebody implanted something on their head, you should not listen. And if your parents say something, call 911 and your parents will go to jail. So, pretty much that is got implanted. So, Trojan and all that stuff is basically malicious implants. So, there are, as I say, there are big spectrum, there are piracy issue, reverse engineering. From the design somebody is trying to figure out what is your intellectual property. You and your team spend millions of dollars to do the research to develop the product, they will just photocopy, right. But today I am going to just focus on malicious modification, and specific instance of malicious modification is hardware Trojan. So, before I go, let me be a devil's advocate. Almost half of the researchers do not believe Trojan exists, they do not, other half do, and even the half do, about 90% of them are not interested in working in Trojan, right. But in early 2007, DARPA, the US defense agency, invested hundreds of millions of dollars in this program. So, that is at the time I got convinced that there is something military cannot tell us, otherwise why would they invest so much of money. There are something, and of course, later we knew we are not allowed to tell. Now, you see all these examples of pager attack and what not, and those of you who do not know the pager attack, you develop a pager somewhere, and in the supply chain when postal departments are sending it, open that, put your trigger in, and then when all these military people of your opponent country are using pager or with them, you just blow them up, so that they can die, you can do the damage, but it is basically nothing but Trojan. So, what I am going to do, I am going to talk about anything you design, although I am going to talk about today hardware Trojan, there are many other attack models. Anything you attack, these are the 3-4 core components you want to talk about. What is the coverage metric? What is the metric? Because in functional domain it is very well defined. What is the metric? Statement coverage, line coverage, branch coverage and all that stuff. In security domain things are evolving, even today it is evolving. I still want to talk about little bit about metric. What is the metric? And once you have the metric, then you want to talk about what are the benchmarks. If you develop a Trojan detection tool, I develop a Trojan detection tool, how do we compare? Because I will run on my design, you will run on your design, and that used to be the case even normal world. Not normal world as in Intel developing processor, ARM developing, AMD developing, everybody is saying mine is better than theirs, because they are running their own designs. Then came the consortium about 20 years ago called SPEC. So, people from different companies came together and tried to decide, okay, these are the 10, 20 benchmarks that every processor company should run. Now, it is very interesting game actually. When Intel wanted to push one of their design in very forcefully, other people will know. So, they will try to push it back. So, if you are doing a horse racing and if the person who reaches last wins, then you cannot drive your own horse, you have to jump to other person's horse, try to race it as fast as possible to make that person lose. And it's unless you sit in that table, you do not know how it goes. If you wanted to push your benchmark, you try to pretend you do not want that to happen. Even the same analogy, this tug of war, oh, I do not like this benchmark, this is unfair, then other people will think, oh, this is probably a disadvantage for this company, let us push it in, and that is exactly what you wanted. So, static and dynamic benchmarks I will talk about, then I will talk about something little more interesting, which is how do you discourage attacker from inserting Trojans in a design. So, which is rareness reduction. So, you know what Trojan is. So, key idea is not, it is not important what the story is, key idea is how can I hide in such a manner so that nobody else can identify it, but I can take advantage of it when I want to take the advantage. That is the key idea of Trojan. And before I talk about Trojan, the threat model is important. You hide in rare signal, rare variable. So, I wanted to give you an idea what that does rare mean. We can compute rare in two ways. One is statically, if I give you a design, you can just walk through, find out what is rare, or dynamically through simulation. Whichever way you do, I will walk you through. So, if this is an AND gate, this is the absolute in front input of a chip or your program, first time it is entering. So, we can safely assume the probability of 0 and 1, or this is 1, this is 0 is 50-50. That is how we are going to give the input, right. You can control that 50% of the time that value is 0, 50% of 1. But once it goes through the AND gate, if you remember the truth table, output becomes 0 3 times and output becomes 1 only once under 4 possible combination. So, it should not be surprised the 0 probability is 0.75 and 1 probability is 0.25. So, similarly, if a multiple layer, I am not going to show you the math, but this is another layer of AND gate, this is what will happen. The interesting part to observe, the probability of 1 was 0.5 here, it became 0.25, it became 0.125, it is getting reduced. So, if you have a significant layer of AND gates, the probability of that value being 1, if it is an AND series, is going to go down significantly. So, that makes it rare. And so, typically there are two terminology people use, it is not important. Given a variable, what is its rarest of number. So, for example, if we are interested in x, should I take it as a rare signal if I am an attacker to hide behind it? Is it rare enough? Whose is the rare one? So, basically under value 1 x equal to 1, that has a 0.125 probability of being 1. Is it rare enough? That is different. In the whole circuit, what is the rarest value? That is in this example, it still happens to be the same. Another design, if x I wanted, the rarest value is 0, x equal to 0, that is the rarest value. What is the rarest story in the whole circuit? It is this one. I did not give a name for this variable, but whatever this variable is, under 1, 0.25 is the rarest value in the circuit, and for a specific signal this is the rarest value. Is these two concepts clear? What is the rarest value of a signal or of the whole design? Of course, one signal is not important, eventually we will consider many, but I want to have a feeling that you know what rare means. Yes, please. You can say, I can repeat.
Sir, why the probability gets reduced in AND gate and probability gets increased in OR gate?
Oh, because that's the truth table, right? When you have A and B and 0 1 1 0, what am I doing, 0 0 0 0 1 1 0 and 1 1, if you look at the values, the way it produces 0 0 0 and 1. So, probability of 1, it is 1 in 4 in case of AND gate, but in case of OR gate probability of 1 is 3. So, that is why probability of 1 increases, another one decreases. Even here you see the OR gate, this one is decreasing, but 1 is increasing. Any other questions? Okay. So, all right. So, now that we know what rareness means, how we want to hide, how would you do in a dynamic environment? You take the design, simulate it, apply random inputs, millions, more you give it is more accurate. If you run 5 or 10, that is not so accurate. If you run millions of test cases, then for every signal you count how many times it is 0, how many times it becomes 1, and once you have that, then you compute the percentage. And but the thing is, what is rare, what is not rare, a designer has to choose what do you call rare, right. So, for example, if I go back to the previous signal x, and if it is 0 for 90% of the time, then that means it is 1 for 10% of the time, right. So, that is basically, and if that design we say rareness threshold is 0.1, so then we select that signal, we as an attacker select that signal as a rare. But somebody may say, yeah, 10% is not rare, we really want something. So, 0.1 is 10%, we really need somebody 0.01, 1%, somebody say even 1% is not rare. Now, can anybody tell me why are you so, as an attacker, why am I so much after rare signal? How is it helping me hide? Here at least I know this is a broad daylight, this is visible, here there is darkness, I can hide there. But here what is the hiding? You can still see the circuit, you can print it. Remember, we are still talking design stage, not in fabrication stage. What is the hiding business with rare? How does that connected?
Because the vulnerability will be observed only at that specific signal will be the trigger.
Right. So, the thing is, one thing I did not say is that if you have a rare, so two things, if you have a design, assumption is we won't, during simulation we won't be able to run all possible inputs. If we can run all possible inputs, attacker has no place to hide. No matter how rare it is, if you run all possible signal, at some point that signal would be activated or that trigger would be activated, and if it is a functional Trojan which changes the functionality of the device, changes a green light to a red light, then if I have a golden design, I am comparing the output would be different, I will be able to catch it. But assumption is number of input is so much, in a typical SOC it is about 300 bits, about 2 to the power 300, we could not try those many inputs in lifetime of the universe. So, if we cannot run those, so that means when you run any random input, the signals that are non-rare, they will be activated, and the probability of signal that is rare, the activation probability is extremely low. Rarest the signal, and remember how did we compute, that is how we computed who is becoming 1 how many times, and in fact most designs, even if you run million, many signal in the range of 10 to 100 signal, activation of one value would be 0, it will never be activated. So, maybe the rare of 1 you will never find 1, the way circuit is designed, about 10 to 100 in a million gate design, they will never be activated, right. And only way you guarantee that by running all possible input. So, this hiding business, rareness business is related to this, because a designer or verification engineer will not be able to run all possible inputs, and rare signal only gets activated in extremely rare scenario, and attacker knows that scenario, which input would activate it, attacker knows that, and that is where attacker hides. Any question? So, that is why we are computing rareness, the signal, and the key idea is if I insert a Trojan during normal verification time in the company, nobody will be able to detect it. If your company run 1 trillion test cases, that should not be able to activate. And to make it even more interesting, what designers do is even more smart, which is they do not take one rare signal, they take n of them. In this example, I am taking one rare signal, let us say this is 0.1 probability, 10%, remember 10% is not really rare in standard world definition, this is 0.1. I want to see hand how many can tell me what is the probability of this output. If the input is 0.1, what is the probability of this output for x equal to for value 1 if this variable is x. You already saw the static computation, right. This is dependent or independent probability. First, this is dependent probability. Even if you did not know this gate, if you did not know this gate, it is still 0.1 times 0.1. So, it is going to be 0.01. But if you know this is AND gate, then the truth table whatever you saw, right, 0.5 becomes 0.25, but typically it is 0.1, 0.1. So, it is like it is going to be, if you do not know this, then it is going to be about 0.01, simple multiplication. That is not accurate. Now that you know AND gate, you have to do the truth table thing. So, basically this is for 2 input. If you make 3 input, then it becomes 0.001. 4 input, it becomes 0.00001. That probability become like ridiculously small for anybody to ever activate it. So, any number, we did some research here, any number greater than any, if you create something greater than about 10 or 12 I believe, then it is basically theoretically impossible even to activate it. The probability is 1 over 2 to the power 12. Now, you would argue who would insert such a big AND gate? Now, do I find so many rare signal? Yes, in a million gate design you will find so many rare signal, but who will put a AND gate with like 12 inputs? Nobody will, because then you can just see the design and you can figure out. They will do a chain of that and they will hide that chain. So, chain as in, if you want to do a 3 input AND gate, you will do this. You still have 3 input AND gate, but you will not create one big AND gate. In fact, most of the synthesis library you do not have 8 input 16 input AND gates. You still have to choose from 2 input or 3 input AND gates that they have in the library, but it is basically a chain. So, in early days research people used to put chain, then the defense mechanism was if there is a AND chain, that does not look like a normal design, let us get rid of that elimination. Then people realize they try to hide it, but no matter what it is the key idea clear that attacker's job is to make this trigger condition really extremely rare. So, Trojan has 2 portions, one is trigger which I was talking all along. Now, I am going to talk about payload. Trigger is like a trigger of a switch that Israel did, press the button whenever they are unhappy with that, and that is it, that blew those pagers, that is the trigger. Now, blowing the pager, killing the people, that is the payload. Here in this example, just by looking at the circuit, can anybody tell me what is the payload here, what is it trying to achieve? Anybody please, just turn on your mic and please say it. What is the payload here? What is trying to achieve here? If this trigger gets activated, becomes 1, what does it do? It flips this signal. So, this is your design. So, which part is design? All of this is your design. Think of millions of gates. You only added these 2 extra gate, one trigger gate, one payload gate, XOR gate. In this particular design, trigger you understood, right, extremely rigor. When it becomes 1, you mark it 1, okay. Attacker is able to find primary inputs, attacker knows the primary input, that will make this line 1. When it becomes 1, if this line is 0, what would be the output? Okay. Let us take a different color. If this line is 1, what would be the output? So, do you see, if this is 0 it becomes 1, if this is 1 it becomes 0, that means it flips the value. So, if traffic light is supposed to be green on one side, you make it red, supposed to be red, you make it green, you change the functionality. So, this is a very simple Trojan. This is also known as combinational Trojan because it relies on combinational logic, and the idea is you create an extremely rare trigger condition, an attacker can relax and sit, and whenever wants to trigger the switch, it would trigger, and what would it do? It would change the functionality. For information leakage, it may drive your car to the ditch, it knows when exactly you are on top of a bridge or something, that is exactly when it will malfunction, and it will take a left turn and it will go down the drain or river or whatever the objective. It basically flips the story. Let us say you are running in a user mode privilege mode is 0, super user mode is 0, and this will change that super user bit to 1. This is not a laser fault injection attack. In laser fault injection attack, you need to know, you need to be in the vicinity, point to the chip, you have to know where the register is. Here you earlier embedded it, and whenever I feel like I will attack you. Maybe today you are friendly to me, tomorrow you are not, so I will basically attack on you. So, most of the attackers, they basically implant things on everywhere. They may not use them in their lifetime, but if needed they will. This is an exploitation technique. Any question? So, this is the key idea. Now, we will build on top of it. Yes, please.
How the rare condition happens? Someone need to provide some kind of stimulus input, then only the rare condition.
Rare condition happens meaning who makes it 1? See, the input, a specific input will make it 1.
But input need to come from somewhere else, then only attacker need to come.
Right. So, the triggering mechanism can happen in different ways. If you think of a pager attack, so these have transmission devices, they have reception device, very tiny, so that Israel military can sit in the inside Israel, trigger that, and that would receive in Syria in front. So, that whether it is a wireless, where, near, far, that is an independent discussion. You have to have that mechanism inbuilt, like the kill switch example. A country won the war by killing, destroying the planes in the sky. So, kill switch mechanism was designed for a legitimate purpose, that if it is in enemy hand, you destroy itself. So, that enemy cannot figure out how your airplanes work. But the other country basically put a Trojan in the kill switch, so that it can fake and tell the system I am in enemy hand. So, that is again wirelessly transmitted signal. So, these input values could be wirelessly, could be there, near, it could be your computer, I just press Control Shift something and it basically destroys your computer. I may have access, may not have access, but that the idea is what value would create that trigger condition, that attacker knows. How you deploy that input, that is a different story. Any other questions? Yes, please. None of them? Okay, go ahead, I will repeat the question.
Okay, sir. So, this thing you are talking about in design phase.
This I am talking about in design phase,
Okay.
but this will work even. So, the question is whether it is in the design phase, I am talking in the design phase, but this will work in any phase. Think about a fabricated circuit or a computer. If you know in computer which keys to enter to apply to create a trigger, you can just do those keystrokes that would create certain set of values, and then whatever effect it is going to print something on screen. My girlfriend's name would print on the screen, that is what will happen. So, what is the payload, what is the trigger, whether it is fabricated, non-fabricated, it is different, but it has to be embedded in the design. Again, it could be in the design stage, it could be in the fabrication stage, it could be in the assembly stage. I will show those Trojans also. Somebody putting chips together, Trojan is not inside the chip, but when you are putting different chips, memory and software, at that stage you put in, right. And most of the attacks are when they are collaborative attack. Software will help hardware, who will help somebody, and then they will get data from somewhere, they will forward data to somewhere else. There are a lot of interesting ones. Right. Any other questions?
Sir, but how as an attacker I can get information about all the rear signals happening here, because rear signals and the where it is in designing phase or fabrication phase, it should come from an insider attacker. But how an outsider attacker I can analyze all the things and get the information about what input will create what output?
Yeah.
How?
So, very interesting question. So, two assumptions here. Assumption is attacker knows everything about your design. Attacker has access. If attacker does not have access, how on earth they are able to put it in, connect signals and all that stuff. So, attacker knows your circuit, attacker knows who the rare signals are, and attacker knows which one to make one. So, that is the first point. Second point is how does attacker know what value to, because attacker knows this needs to be 1, there is a technique called ATPG, I will speak in like half an hour, 1 hour later. That ATPG technique you can go back from here and automatic test pattern generation, you can find the pattern. So, attacker has done that in house. Attacker exactly know the trigger I am trying to make, what is the exact input that would create that trigger, because otherwise all the effort of the attacker is useless. Attacker knows that. You and I do not know if we are the verification engineer, because if we do not know if there is a Trojan, number one, and even if there, unless we try all possible combinations, that line will not get activated. The probability of that line getting activated is extremely rare, that is why we call it a rare trigger. Any other questions?
One more. Last
Go
one.
ahead.
Okay, so you are talking about rare signals. So they are the primary cause of 0-day exploit, yes or no?
0-day exploit, not necessarily. From a designer perspective, it could be 0-day exploit. From attacker's perspective, or if you believe it is a threat model of rare, as I go along, threat model may not be rare. It just it makes it simple to discuss. So basically, it is not that you do not know, you know. So you do not know malware would be installed in your computer or ransomware, you do, but it is just that you are not able to protect it, right. Okay, so now let us zoom into if you are a designer, how would you design for a typical combinational Trojan. It could be your C Java program, it could be VHDL Verilog code. The key idea is you look at the variable, figure out who is rare under what value, and remember we talked about binary signal. It could be a variable in your C program with 32-bit number, you have 2 to the power 32 possible values. For one of those values it is extremely rare, and which has a higher likelihood, because each of the values probability is, even if it is a uniform distribution, 1 over 2 to the power 32. So, a very specific pattern of 32 value, if you use that, even in this one it is like extremely rare. So, this if you are a computer science or programmer, this is kind of the view. If you are a kind of from computer engineering EC, then the view would be, well, I find who is the rare signal, I create a trigger, then create a payload, and that is basically the view, right, simplistic view. Any question on combinational Trojan or how you would design a combinational Trojan? Let us look into the sequential Trojan. Sequential Trojan is much more powerful from attacker side, much more difficult for the verifications person side. So, you have a finite state machine with lot of states and transitions, and then attacker is going to do the same thing, the way they did rare value variable analysis. They will be running this with millions of tests and trying to figure out which transition is rare, and most of the time a vast majority of transitions are rare, because they are never activated. So, then who is rare, and as you realize, if there is a if statement which is not activated, anything inside that if there is another if inside, that would also not get activated. Anytime rareness hits, anything in that subtree, everybody is rare. So, if you have a if statement, for example, so if you have a if and then inside a very rare condition, and inside that there is another if this turns out to be rare, and most of the time in analysis rare basically means it never got activated, or one of the specific path. If so, for example, if I draw pictorially, this is a if else, then this is another if, there is else. So, you already have 4 possible paths here, right, 1, I do not know, 4 or 3. So, basically maybe this particular path is kind of rare, it did not get activated. So, that means a Trojan can easily hide somewhere here, somewhere there. So, that is basically the key idea, but nonetheless so when you think of sequential logic, think of branch statements, for loop, any kind of conditional view, and if you want to look from a computer engineering perspective, then think of a counter, and a specific value of that counter is what causes the trigger condition, but your payload is still similar. Now, I am still using XOR gate, because I am assuming payload is functional alteration, functional change, you just flip the decision, but which count, which transition, that is basically a counter. For a specific value of that count, you trigger. If counter is controlled by a clock, we call it synchronous counter, If counter is controlled by some asynchronous variable, we call it asynchronous counter. And this one I said maybe I as a attacker did not have access to when the processor got designed or memory got designed, but I have access to, I am a system integrator side. Let us say I am working in Apple or Samsung or Sony, Toshiba, Hitachi, all these big systems companies. Then I am sitting there, then I can again I still have to know a lot. I have to know that when computation is going on, if certain information floating on the bus that indicates, then at that point memory would have the key, unencrypted. So, that is important. So, this is memory and we have the key at that point unencrypted. So, then what I can do, when certain information is here, I get to hear that. So, that is my trigger, a specific value here is kind of a trigger, and then I am going to either modify certain value in memory. In this particular example, I will try to read it and maybe wirelessly transmit, send it to another malicious software running, that is a different story. So, how do I trigger and how, when I extract the value, whom do I hand it over, that is kind of a difference. The spying activity, spy network, all that stuff you have to worry about. So, this is kind of system level Trojan, and there is a lot of work on PCB level Trojan, and there are many examples of that. Any question on system level Trojan? If you view this as an integrated circuit, then this is also not system level Trojan, bunch of components and you are putting your trigger and payload somewhere. So, the idea of trigger and payload remains the same. Now, we designed a tons of Trojans, and Trust Hub, when you have a computer, if you log into trusthub.org, we put all of those Trojans there, different types. Combinational trigger I kind of talked about, a very simple one, but if I am an attacker, if I know you are detecting based on rare, I would combine some rare and non-rare. Of course, mathematics says it is a bad idea, because probability of detection if you combine rare and non-rare is basically detection is higher, but no matter what it is, if I know you are doing something, I want to evade that. If I know you are looking at the bottom of the table, then I will put the camera in your hotel room right there. You won't even suspect. Nice flower vase and nice stuff, camera is embedded there. You won't be looking for it there, right?
Excuse me.
Yes, please.
One doubt, sir. Like we have spoken about the triggers, which can be combinational or sequential circuits, but in both they trigger a particular payload. So the malicious circuit is the payload itself, and that has to be integrated within the hardware itself, or can it be a software based payload which is the malicious part?
Right, interesting question. So, the question is trigger could be combinational and sequential, but the payload, should it be integrated in the design itself or it can work with somebody else. In fact, trigger and payload does not even have to be physically there. If you are collaborating with another entity, trigger could come from software. A software will tell you, okay, now start recording, then software is the trigger. How the software decided that on the earth, that is different. Same thing about payload. Payload is about what do I, at certain opportune moment, what do I do? Do I leak some information, change some information? Those are few choices, and once I decide that, do I store it in a buffer? Remember the example of Xerox 941, the US spy was stealing from Russian consulate. So, basically do I store in an internal buffer, somebody else will come and take it out, or should we just transmit as a signal, somebody sitting in the next room would be able to absorb it, or should I just change the traffic light from red to green, so that some accident, some people die, that is all my objective. So, trigger and payload, it does not even have to be integrated right then and there, it could be in any manner. The easiest examples are, they are all there, few circuits, but I want to dispel your notion, oh I can see my circuit, you can't see your circuit, because, and some people tell me, oh why do not I do just diff of two circuits, because you have to understand that when you want to do diff, it is not just the two extra gate. If you had the golden design somewhere, somebody came in and added two extra gates, you could do the diff, but in general what happens when hands are changing, they are doing something, compilation, transformation, power, dynamic power management logic. So, they are adding lot of stuff, in addition to this got added. So, that is why diff will not work, eyeballing will not work, it is a millions of lines of code, and fabrication time people think, well, I will run 2 circuits and then I will see if somebody is consuming more power. First of all, you do not have 2 circuits, you have only one, and that is why when I talk about AI, we will talk about golden free. Most of the golden free Trojan detection methods are AI based methods. You have only one design, there is no golden design with whom you can compare, number 1. Number 2 is that the notion of process variation, because each of the gate, the amount of power they consume or exact area, it is not identical. If you create millions of AND gate, same fabrication technology, same day, same time, they will have minor, very small minor variation, but if you multiply that by million, then you are looking at a number, looking at a, people say 2 to I do not know, people say 10-12%, even if I do not go for 2, I go for 1% variation in time, power, area, 1% of a million is huge, in the order of thousands of, you could potentially add thousands of gates, still you will not be detected in a chip, in the power and all that. In fact, most Trojans, although I am showing a silly example of 2 gates, it is in the order of 10, 5, 10, 100. So, it is not going to go in the ballpark of 1000, you will not be able to detect in any manner. Does that answer your question? Okay, so, there are many, I am not going to go through laundry list. So, rare we talked about, rare we talked about a lot, and what did I do? Rare we talked. Now, the rare and non-rare combination is possible, then sequential at the programming level it could be rare branches, at finite state machine rare FSM states or rare transition, synchronous we said when it is incremented by a clock, asynchronous when incremented by some event, think of a variable, input variable or something else. It could be a combination of both synchronous, asynchronous, and it could be a sequence of rare event. Think of one counter, when it becomes 5, then starts incrementing another counter, when they becomes 10, it could be a sequence of event. In programming level it could be nested rare statement. Remember, attacker might not have added nested rare statement, you might have had nested rare statement right there, attacker decided to embed there, and then there could be hybrid. Let me show you an hybrid example. So, this is your design, millions of gates, and maybe 2 rare signal coming out, and there is a counter. This is synchronous counter, because clock is incrementing the counter, a specific value of counter, when that becomes, let us say I am just putting a random number 531, when this counter becomes 531, this rare 2 becomes, this is a rare for 0, this is a rare for 1, those 3 will make this AND gate true, and that becomes a counter clock for this counter. When this counter becomes 1, 2, 3, then this is the trigger condition. So, this is a synchronous counter, this is an asynchronous counter. So, there is a sequential, there is combinational. So, this is kind of a hybrid Trojan. An attacker can make it as complex as possible. So, your probability of activation is close to 0. Any question on this hybrid? I am just showing only the trigger part. Similar innovation has been done on the payload side, I did not wanted to talk about, then that is going to take forever. So, there is this whole world of stuff, but from now on I am going to call them rare events, combinational, sequential, branches, non-branches, electrical engineering, computer science, I do not want to talk about it, rare events. So, then all the subsequent discussion I do for detection we will be talking about how do we do detection of the rare events, we will talk about different things. But before I go there, can we stop this attacker embedding a Trojan? What do you think we can do? Knowing what you know now, what can you do to discourage the attacker for embedding a Trojan in your design? What will demotivate an attacker? Because attacker has to invest energy, money, whatever thing has to invest. What will demotivate them?
If you will not get some respective output, I mean in terms of money, or
if they insert, they will probably get something out of it, but that is a good idea that end result is getting let us say ransom, if cryptocurrency is removed from the world, ransomware will go away, but you and I know that is not going to happen, at least not in my lifetime. So, then what else can we do? What is the threat model here? Rareness. If none of the signals are rare, all are equally unrare, then attacker has no place to hide. You try hiding anywhere, normal traditional validation technique will be able to activate it, will be able to detect you, right. So, then there are many methodologies, I will talk about something scientific perspective, but there are methodologies where you give the perception something as rare, but that is actually not non-rare. Something dark is actually in light, something in light has dark. So, in fact, this whole in security community, this whole honey trap business is you are actually inviting, attracting attacker to insert Trojan. In a place attacker thinks it is extremely rare, but from your perspective that is exactly where you are going to look. So, attacker is putting in a place that is exactly where you are going to look. But let me show you something from a scientific perspective. But before I do that, as I said, let us talk about metrics. So, in terms of metrics, what do we do from a, because we are going to talk about lot of detection techniques. If rareness is threat model, remember if threat model changes, all of these changes. Our threat model is attacker is going to hide in rare events. So, then if rare events is the rare nodes, then how the test cases you ran, this is functional Trojan detection. If you do non-functional, I will come to that in a moment, but before that I wanted to show one more design that you probably did not see. So, this particular is always on Trojan. The other Trojan is you trigger when you want, it is always on Trojan, even then it is hard to detect. It is basically emanating the information. If you are doing any electromagnetic attack, then you can get that information out of it. It is always kind of writing to certain value, reading certain value, so that it is always on. There are many such variations, but that I will come to in a moment. But in terms of coverage metric, what I wanted to show you, if you are generating test or whatever you are doing, how many rare nodes you activated, how many rare nodes are in the design, that percentage, that is basically a good coverage metric. Then if you are thinking of rare branch coverage, same thing, number of activated branches over number of overall branches. Trigger coverage, now branch coverage and node coverage is not that difficult, trigger coverage is a serious problem. Anybody knows why? Number of nodes can be counted. Now think of number of signals, you exactly know, million. Number of branches, you know, thousands or millions of branches. Trigger is a problem because nobody told you, attacker never told you whether the attacker created a 2 input trigger, 3 input trigger, 4 input trigger. So, you have all these possibilities. So, that basically means if you have 1 million, forget about 1 million. If you have 100 signal, if you are choosing 100 choose 3 plus 100 choose 4 plus 100 choose 5 to whatever you do, this number is an exponential number. Even if you do not go beyond 6 or 8, this number is an exponential number. Even putting this total number of rare triggers here is an exponential number, and your probability of activating even a small fraction of them is very high. So, that is why the community what they do, they basically, we understand there is an exponential number of possible trigger, you randomly sample that space, randomly sample and choose 5, 10, 20, 100 and try to see how many of them you covered. It is kind of a twisted world, because attacker do not care what you are doing, they will insert wherever they can, but random sampling is the state of the art today. It may seem silly, attacker can hide anywhere, you randomly sample what is your odds or probability you will be able to activate, but that is the best we can do. This is an exponential number. And but the harder problem, even harder problem is the following. Harder problem is now we have all these number, I showed you only 3 metrics, how do I add it up? So, we were part of a $75 million DARPA project, they do not care, they do not want to hear any of those stuff. All they want to hear, I gave you a design, tell me how secure it is. That is all they want to know, they want to know something like this. They want to know from a Trojan perspective, actually they are not even interested in Trojan, they are interested in overall security. I talked about laser fault injection, I talked about FSM vulnerability, Trojan is one, information leakage I did not talk about, So, there are all reverse engineering, all these like the way Professor Karfa talked about, obfuscation and all that. Even if you put obfuscation there, how secure is it? And all these metrics, they want one number. Why? Because when they are doing synthesis, area, power, optimization, they give one number, area is this, power is this, for this configuration. They want one security number, so that they can then do different optimization techniques. If you say, well, for security I am going to give you 200 numbers, for Trojan itself I am going to give you 3 numbers, for information leakage I will give you 5 numbers, for reverse engineering I will give this much number, for side channel vulnerability I will give you that many numbers. What tool can do anything with it? So, the way we kind of tried doing is hand waving, you could figure out some weightage we are giving to node coverage, branch coverage, toggle coverage. If you do not do random sampling, actually these two values have no contribution. These two values have no contribution. Can anybody tell me why? Because this toggle coverage number, this number is so big, they basically dominate the world, right. But anyway, whatever it is, so we kind of came up with this and they are like unhappy about it, you could tell. And it is not just that, even if the number we get for Trojan, we have to do a weight multiplied this plus some number for information leakage, some number for reverse engineering, some number for side channel vulnerability or lack thereof. Even if you do mitigation on top of it, I will talk about some mitigations. Dr. Karfa talked about obfuscation. You want to know, did your security level improve or it didn't, nothing happened or it deteriorated, you want to do that. So, that is why they are interested in getting one number, the way they get one power number, one performance number, they want to get one security number. And in the community people call it a pass optimization, PASS. This is area, this is, what is the other one? Oh, this is power, this is definitely power, that speed which is performance, that security, and this is area. So, area, power, performance and security, these 4 optimizations. When you go to industry, that is all you will be hearing, if your industry care about security, these 4. And let me just conclude with this discussion, that there are 2 ways company these days use this methodology, 2 ways. If you are an engineer joining a company, these are the 2 ways. If you are dealing with Trojans, you deal with another security level, story would be different. You have your design, you are doing rareness analysis, I only give you a glimpse how to compute, then you get your suspicious signals and branches, and these techniques I did not talk about, which I will talk in the next lecture. And through these techniques you kind of basically generate some tests, and somebody, not you, it is a blue hat red hat story, somebody in the company will insert Trojan in your design, take the design, do Trojan insertion, and then you are kind of running these different methods, either to compare the method or to figure out whether your design is good, then you kind of doing this analysis. Now, what does it give us? We are inserting, maybe our one group, we are evaluating, whom does it help? Can anybody tell me? It does not make any sense. I inserted a Trojan, you verified and say, yeah, I can detect the Trojan. How does this help? Think from, you are working in industry, think from that perspective, you are just wastage of money. Yes, please. Absolutely correct. You are doing all this to set up your environment, because your design is going to go all these places in the world. When it comes back, what confidence would you have that your framework would be able to detect the Trojan? Even the Trojan you inserted, if it is not able to capture those, then you know others you will not be able to do. But if you can capture all of them, you have good confidence we did build a good framework. You are just validating your framework. Recall the example I took, if you hired a bodyguard, you hire an attacker, make an attack on yourself to see how bodyguard defends, so that in a real world scenario you know how that bodyguard would protect you. So, this is the same analogy, and this is one way company uses. Another way company uses is Of course, still rareness, this part remains the same. When they have a golden model, and this is pretty much happens in design stage, not in when you have. So, you have a golden model, let us say C program or transaction level model, you may have RTL or gate level model, you simulate and you compare the output. This has multiple assumptions, and one of them is absolutely wrong, which is you have a golden model. Most of the time industry do not have golden model, that is one. Second is it is a functional Trojan. I only talked about function. When I go into trust hub and benchmarks, you will see there are so many Trojans and payload can be in so many ways. Functional Trojan is the easiest one to detect, because you can compare the output, you can figure out, assuming you can activate them. How do we activate? Then you will be saying, if the trigger condition is so rare, how is it able to activate? We will get to that. So, we stop here, and in the next lecture we will talk about Trojan detection. Thank you.